Okay, again the same issue. No one has submitted the homework yet of all the chapters of part second. So for 3D also, I do not receive the assignments. So whenever you will get the time, please complete the homework. Okay, the basic is NCRT. That's why the assignments which I have given you is from NCRT only. So first complete that. Okay. Okay. In this probability, first of all, we will check which portion has been deleted. So please, if you have an NCRT, please mark with a pencil. Page number 572, we have a topic Bernoulli's trial. Okay, Bernoulli's trial. So that is exercise 13.5. This exercise has been deleted. Okay, this has been deleted. Okay, the complete exercise 13.5. So that is now we have to complete only 4 exercises in this probability. Next, on page number 578, we have some examples which are related to Bernoulli's trial. So please delete this one. Example 34, example 35. Okay, this has been deleted. This is deleted. Then we have a miscellaneous exercise. Miscellaneous exercise. Okay, and it is on page 583. In the miscellaneous exercise, please delete these questions. Question 5, question 6, question 9. This needs to be deleted as it is of Bernoulli's trial. Okay, so please note down this. Raise your hands once it is done. Then we will start the chapter. All of you, please raise your hands if it is done so that we can start the chapter. Uh, okay, Saf, okay, Nabi. Atif, is it done? Shall we start? Atif, I guess you have some network issue. I'm going to start the chapter. Okay, let me know if you miss anything. So the chapter is probability. Okay, I hope you remember all the terms which were there in class 11. Okay, so we will do a quick revision of 10 minutes of the terms which you have studied in class 11 because the same will be used in 12th also. The first is random experiment. Okay, you know what is a random experiment. Throughout the probability, you will see this term, random experiment. Okay, if in it's your wish if you want to note down this definition, well and good. If you already know, then it's your wish. Okay. If in each trial of an experiment conducted conducted under conducted under identical conditions The outcome is not unique. The outcome is not unique, but maybe of any of the several possible outcomes, then then such experiment then such a experiment is known as random random experiment. Okay, so what's a random experiment? If you are performing an experiment and you are not getting the same outcome every time, you are getting a one of the several possible outcome, then such experiment is called random experiment. For example, if you are tossing a coin, then sometimes we are getting head, sometimes we are getting tail. That's why we will say that it's a random experiment. Okay, because every time we will not get a tail, or every time we will not get a head. We can sometime we will get a head and sometime we can get a tail. So that's why the experiment is called random experiment. Okay, if you already know this term, then it's fine. There's no need to note down this. Okay, this complete is of 11th class outcomes. Anyone can tell me what is mean by outcomes? Nabil, Saf, Atif, what is mean by outcome?
The possible results you get.
Yes. Okay, the possible results. Okay, a possible result, of a random experiment, of a random experiment. Okay. Nabil, can you tell me what is a sample space?
All the possible outcomes of
All
a
the
random.
possible. Yes, that's correct. Very good. So what is a sample space? The set of all possible outcomes. All possible outcomes. Okay, in a random experiment. So I will write this one only. So if you wish, note down this. Please raise your hand if I can change the slide. Okay. All of you, please raise your hand. I can change the slide. Okay, so Saif, okay, Nabil, Atif, is it done?
Yes.
Okay, next one. Next is event. Who can tell me, Saif? Can you tell me what is the event in probability? Nabil, can you tell me what is the event? Atif, can you tell me what's the event?
It's a subset of sample space.
Very good. Every subset of a sample space, every subset of a sample space is called an event. It's called an event. Okay. So, for example, if we throw a die and we will get this one, 1, 2, 3, 4, 5, 6. Okay. So we can say that E is a event. We will say getting a even number. Getting a even number. So you can see that it is a subset of the sample space. Okay. So event is nothing. It's a subset of sample space. Now we have a different type of event. For example, impossible event. Okay, leave this. We do. Okay, I have started. Who can tell me what's a impossible event?
Event which has probability 0.
Yes. Okay. For example, if you're throwing a die and I ask you what's the probability of getting a 7, if the die consists of the number from 1 to 6, and I ask you what the probability of getting a 7. So 7 is an impossible event. Okay. Similarly, what's a sure event?
Event with probability 1.
Yes, which always occur. Okay, for example, if we are tossing a coin and I tell you that E is the event. So in throwing a coin, E is the event, of getting head or tail, of getting head or tail. Okay. So if you will throw a coin, every time you will get you will get a head or a tail. So that's why it's a sure event. Okay. Next, uh, mutually exclusive event. This is very good. This is very important. Who can tell me what's a mutually exclusive event? Nabil, can you tell me this? Steph, can you tell me this mutually exclusive event? Atif, two events are said to be mutually exclusive. Okay, two events are said to be mutually exclusive if E1 intersection E2 is equal to null set. Okay, so that means if there's nothing common between the two events, then we will say that they are mutually exclusive. For example, if we are throwing a die, then getting a even number and getting an odd number. If we have a event getting an even number, if we have another event of getting an odd number, then these two are mutually exclusive events because there is nothing common between them. Okay, so this is very important. You can see this term in some questions in class 12th. Okay, so what are mutually exclusive? If there are certain events in which there is nothing common. Okay, so please raise your hands if I can change the slide. Okay, Zaf. Okay, Nabil. Is it done? Shall we start next?
1 minute.
Okay.
Done.
Okay. Next is exhaustive events. Exhaustive events. Okay. If E1, comma E2, and so on up to En are n events of a sample space and even union. Okay, I hope you all know what is union and intersection. Okay, let me know if anyone have a doubt. If even union so on up to En is a sample space, then even comma E2 up to En are called are called exhaustive exhaustive events. Okay, so what are exhaustive events? Events are said to be exhaustive events if you will find a union of all the events and you're getting the sample space. Okay, we will take example. For example, if we throw a die, then we will get the sample space 1, 2, 3, 4, 5, 6. Okay, if I will give you even is the event of getting even number, getting even number. So that means even will consist of what? 2, 4, 6. E2 I will say getting odd number, getting odd number. Okay, so what is E2 then? E2 is 1, 3, and 5. If you will find E1 union E2, then you will get the complete sample space. Okay. So if you have some events, if you will find the union and you are getting the complete sample space, such a type of events are called the exhaustive events. Okay. Please note down this, raise your hands, then we will start next. Okay, sir. Very good. Atif and Nabil, please confirm. Okay, Nabil, Atif, is it done? Okay, okay, great. Mutually, next is mutually exclusive and mutually exclusive and exhaustive. Mutually exclusive and exhaustive events. Okay, so what are mutually exclusive and exhaustive? Merge these two definitions. What are mutually exclusive? When the intersection is null set. Okay, and exhaustive when the union is sample space. Okay, so if the events are both mutually exclusive and exhaustive, then such events are called mutually exclusive and exhaustive events. So which are events both which are both mutually exclusive and exhaustive. Events which are mutually exclusive and exhaustive are called are called uh, we will write this one. Okay, events which are both mutually exclusive and exhaustive. For example, S is 1, 2, 3, 4, 5. We throw a die 6, and we will say even, getting even number, and E2 we will say getting odd number, getting odd number. Okay, so these are mutually exclusive and these are exhaustive events also. Okay, all of you please note down this, raise your hand. Only 3 definitions more, then we will start 12th probability. Okay, Nabil, good. Atif and Saf, please confirm. Atif, Saf, is it done?
1 minute.
Okay. Okay, okay. Saf, please confirm, okay, once it is done.
Done, sir.
Okay, great. Now next is complementary event. Complementary event. Okay. What a complementary event every for every event A, there there corresponds another event A dash called the complementary event to A, called the complementary event to A. It is also called not A. It is also called not A. Okay. So for example, A is a event of getting an even number. Then A naught will be an event of not getting a even number. Okay. So complementary means not. Please note down this. Again, raise your hands. Okay, Nabil, good. Atif and Saf, is it done?
Yes, sir.
Okay, okay. Then next is event A or B. Okay, so A or B means A union B. Okay, next is event A and B, event A and B. Okay, so A and B means A intersection B. Okay, after this we have a probability formula, probability of equally, probability of equally likely outcomes, likely outcomes. Okay, so what is mean by probability of equally likely outcomes? Means any number of outcomes which are there in the sample space, the probability of each outcome is same. For example, if we are throwing a die, then we have these possibility 1, 2, 3, 4, 5, 6. Okay, now if you will find the probability of 1, then it will be 1 by 6. Probability of 2, it is also 1 by 6. 3, it is also 1 by 6. 4, 1 by 6. 5, 1 by 6. 6, 1 by 6. Okay, so each of these elements have the same probability. That's why that's why these are called equally likely outcomes, because each of these elements have the same probability. Okay, so we are doing this definition considering that the all outcomes have the same probability, that the outcomes are equally likely outcomes. Okay, in case the outcomes are not equally likely, then we can't use this formula. Okay, so I will write PE. So what is mean by this? This is number of outcomes favorable to E, number of outcomes favorable to E, okay, by total possible outcomes, total possible, by total possible outcomes. Okay, this formula also you have done last year. Okay, so please remember that we are doing this formula by considering equally likely outcomes. Okay, in 12th book, there is only a single question where the outcomes are not equally likely. Okay, so to avoid any confusion, we will do that question at the end of the chapter when we will complete a chapter. Okay, that question is in the example. Now the probability of E. Anyone? Okay, let me tell you this. So probability have the minimum value 1 and the minimum value 0 and the maximum value 1. So we can say that the probability is greater than equal to 0 and less than equal to 1. Okay. Now please note down this, raise your hand, then we will start the 12th topic. Okay, Nabil, Atif and Saf, please confirm if it is done. Is it done, Atif and Saf?
No.
Okay, Saf, is it done?
Yes, sir. Done.
Okay, great. Okay, so now we will start the 12th topic, and that is conditional probability. Okay, first of all, we will understood that what is a conditional probability. Conditional probability. Okay, we will take example. Suppose we have a three coin. We are tossing three coins. We are tossing three coins. Okay, then who can tell me? Saf. Saf, please tell me what is the sample space. Okay, coin have head and tail. So if you're tossing three coins,
Head.
very good,
All three head.
very good. Then
Head.
HH, good.
Then head.
HTH, yes,
Head.
good.
Uh, head,
HT, good,
head.
good,
Head.
good.
Triple tail.
Okay, so the total is eight outcomes. Okay, so if I will say that E is the event of getting at least two hit, at least two hit. Okay, so Nabil, can you tell me what is the event E? Or you will
Sir, H.
okay,
HHT,
just give me a minute. A is the event of getting at least two hit. So A is you are saying triple H. Okay, then
HHT,
good,
HTH,
good,
THH.
good.
That's it.
That's it. Okay. Now what will be the probability of A? Nabil?
1/2, sir.
Very good. So favorable of four. Total in the sample space are eight. So we are getting 1/2. Okay. Now next is B. B is getting tail on the first coin. Tail on the first coin. Okay. We have a three coin. Okay. We are getting tail on the first coin. First coin. So Seth, please tell me what the B we will get. Seth, what is B?
3/8.
First tell me all the outcomes.
A tail, head.
Tail, head, good.
Tail, head, tail,
Tail, head, tail, good.
and triple tail.
Triple tail. Okay. So we have eight here. So first you have taken this one. Second you have taken this one. Third you have taken this one. Okay. Okay. Uh, just give me a minute. Okay. Now what's the probability of B?
3 by head. 3 by
Three by eight. Okay. Very good. Now if I will tell you that find the probability find the probability of A when B has already occurred. When B has already occurred. When B has already occurred. Okay. So if I will say to you that find the probability of A when B has already occurred, B has already occurred means on the first coin, you already know that you are getting a tail. You already know that on the first coin, we have a tail. Now you need to find the probability of A. Okay. So in such a case, what you will do? Earlier, what you were doing, you were tossing three coins. Okay. And you are finding the probability. Now in this case, I have already given you that the first coin consists of tail. So there is no significance of these outcomes. Okay, we know that these will never happen. These will never happen. Okay, why we are canceling these? Why we are canceling these? Because we already know that the first coin have the tail. So these outcomes can never happen. Okay, now what we will do? What the outcomes we get now? This, and this. Only three outcomes. Now what is the probability of A? What is A? A is getting at least two hit. So in this one, two, three. What are favorable outcomes? Number of favorable outcomes is Seth, can you tell me from these three, what is the favorable outcome?
D head.
T H H. Okay, because A is what? A is getting at least two hit. Okay, so at least two hit means here only. So here we have a one, and what are the total outcomes we have? One, two, three. Okay, so we are getting 1 by 3. Okay, now uh, so whenever we will put a condition, then this event has already occurred, then what will happen? From the sample space we will remove rest of the outcomes, because these outcomes can never happen. If we already know that the first coin have a tail, then obviously these will never happen, so we will remove this. Okay, and this is called the conditional probability. So if they are saying that find the probability of A when B has already occurred, then we will remove these terms. Okay. And in the denominator, we will take only the terms which are uh, present in the event B. So we will write this formula PA by B. Okay. So this means probability of A when B has already occurred, probability of A when B has already occurred, already occurred. Okay, or probability of A, taken B as the sample space, taken B as the sample space. Okay, so if you have seen here, then here we have taken B as the sample space. From the sample space, we have removed all these terms. So what are these? These are the outcomes which were present in B. B, what was B? THH, THT, and TTT. Okay. So what we have done, we have taken the sample space as B because B has already occurred. So we can say that PA by B means probability of A when B has already occurred, or we can also say that probability of A taken B as the sample space. Okay. Now here we have done this directly, but we will find out a formula. So formula is conditional probability is always written like this. So the formula is N A intersection B by NB. This is the formula. If you will see here, then what you have done, how you get a one here, you have find out the intersection between these two. Okay, here we have written this directly, but how we get a one, we find out the intersection between these two. Okay, so we will get an A intersection B, and the denominator we have use B. If you will divide this with the complete sample space, A intersection B by N sample space by NB by N sample space. So we will get what? B A intersection B by B B. Okay, so this is our formula. P intersection B is probability of A intersection, sorry, PA by B is probability of A intersection B by probability of B. So you can use this one or you can use this. Okay, so there's no need to note down this one. So note down this heading, conditional probability, then write down this formula and let me know if anyone have a doubt. I will again explain this to you. Okay.
So can you say again, sir, how to find probability of A when B has already occurred?
Yes, I will. I guess we have done some mistake here. This is HTT, this is THT, and this should be TTH. Okay, this should be TTH. So if this is TTH, then here also we will get a TTH. Sorry. Okay, so PB is 4 by 8. 4 by 8, and this will be intersection 1 by 4. Sorry. Okay, we have missed this. Yes, Nabil, what's it out?
Sir, can you say how to find probability of A when B has already occurred?
Okay, if they're asking you to find out the probability of A when B has already occurred, okay, so that means what you will do from the complete sample space, you will remove all the outcomes which are not favorable to B. Why? Because we already know that B has already occurred. We are tossing a coin, and I tell you that the first coin will always be a tail. So you know that this, and will have no significance. Is it clear, Nabil? This,
Yes, sir.
these will never, these will never happen. First coin can't be a head because it is already given that the first coin is a tail. So what we will do from the sample space, we will remove these terms. So what the rest we get? THH, THT, TTH, TTT. So we get this B. So that means from this B only, now we need to find out A. What is A? A is getting at least 2 hit. So now our sample space is not this, sample space is this. Now from this one, Nabil, we need to find out getting at least 2 hits. So what is the favorable outcome, Nabil? Number of favorable outcome? This one only?
Yes, sir.
Okay, so favorable is 1. What are total outcome? Total are 4. So it is 1 by 4.
Yes, sir.
Okay. Now by the this we have done directly, but if you will analyze that how you are getting 4, what is 4? 4 is number of elements in event B. Is it correct?
Yes, sir.
Okay. And how you're finding the numerator? You're finding the common term between A and B. From this, in this, you're finding the common term. Okay. So that means in A intersection B. We have done this directly. I asked you to find out uh, at least 2 head from the set B. But how you're finding? You are actually finding the common element between A and B. What is meant by common? We are finding the intersection. Is it clear, Nabil?
Yes, sir.
Nabil, is it clear?
Yes, sir.
Okay, so now we have just find out this formula. We have divided this with sample space, both numerator and denominator. So in the numerator, we will get a probability, and the denominator also, we will get a probability, because this is what, this is actually a probability. A intersection B by complete sample spaces, PA intersection B, and NB by NS is probability of B. Is it clear?
Yes, sir.
Okay, great. So all of you, please note down this, raise your hands, then we will start some questions. Okay.
Sir, what is NS?
Okay. NS is number of elements in the sample space. Number of elements in sample space. Okay. So this is what number of elements present in B. This is number of element present in sample space. So this is what, this is nothing. It is a probability. This is the formula probability favorable by total. Is it clear, Nabil?
Yes, sir.
Similarly in the numerator, favorable by total. So it is again a probability. Okay. So please note down this, all of you. Raise your hands, then we will start question. Everyone, please raise your hands once it is done, then we will start the questions. Okay, Nabil, very good. Atif and Saf, is it done? Atif and Saf, is it done?
Yes.
Okay, Saf, is it done?
1 minute, sir.
Okay.
Yes, sir, done.
Okay. Please try this question. Uh, fair dice. Okay, fair dice means all outcomes are equally likely outcomes. Okay, a fair dice is rolled. Consider the following events. Consider the following events. A is equal to 1, 3, 5. B is equal to 2, 3, and C is equal to 2, 3, 4, 5. Okay, find first is PA by B. Okay, so this means B has already occurred. And next is PB by A. Second is PA by C. Okay, share your answer one by one and let me know if anyone have a doubt. Third is PA union B by C and PA intersection B by C. Fourth is PA intersection B by C. Please try this question. Do this one by one. Okay.
So the fourth question, second part is same as the third question, right, sir?
Fourth.
Third and
Yes.
fourth question.
Yes, yes. I'm sorry. Okay, so I will remove this. If anyone have completed this, please share your answer one by one.
Sir, is P of A given B is 1 by 2.
Good.
P of B given A is 1 by 3.
Very good.
And second one is 1 by 2 and 2 by 3.
Good.
And third one is 3 by 4 and 1 by 4.
Very, very good, Nabil. It is correct. Very good. Atif, Saf, is it done?
1 minute.
Okay. Atif.
Doing
Okay.
so, first one is 1 by 2 and 1 by 3. Second one is 1 by 2 and 2 by 3. And third one is 3 by 4 and 1 by 4.
Very good, Atif. It is correct. Saf, is it done?
The first one getting 1 by 2 and 1 by 3.
Good.
The second one 1 by 2 and 1.
Second is 1 by 2 and
1.
no, it is 2 by 3. Okay. What's the third one?
3 by 4 and 1 by 4.
Very, very good. So you have done a mistake here. C by. Okay. So this means P C by A is P C intersection A by P A or N C intersection A. So whatever formula you wish, you can use it here. Okay. So C intersection A. C is this and A is this. So what is the intersection? 3 and 5. So we can say 2 by 3. Is it clear, Saf? Okay. Please correct this. Now I will give you a second question. A coin is a coin is tossed 3 times. Find in each of the following. Head on the third toss. F is heads on first two tosses. First two tosses. Second is E is at least two hits. F is at most third is at most two tails. At least one tail. Okay, please try this question.
So for the first one, I'm getting one. Is it correct?
Yes, F. Which one?
For the first one, I'm getting answers one.
One. No, Sav, that's not correct. So what we will do, Sav, first of all, we will write the complete sample space. Okay. We will form our events. Then we will solve it. Okay. So triple H, HHT, HTH, THH, then HTT, then THT, then TTH, and triple T. Okay. Now the first one, E is head on the third toss. So head on the third toss. So this one, this one, and this one. So HHH, HTH, THH, TTH. Okay. Now next is F is head on first two tosses. Head on first two tosses. So this one, then first two tosses. Okay. So only these two. Triple H, HH, T. Okay. Now we will find the first of all intersection. So what the intersection you are getting, Seth?
Triple H.
Only one. Okay, and F is 2. So what mistake, Seth, you have done here?
I failed to do the F1.
Okay,
To got F.
okay. Now please correct this and start second part. Anyone else, if have completed the first one, please confirm the answer.
The first one is 1/2.
Yes, Atif, that's correct. Very good.
Can you say the difference between at least and at most?
Seth, your voice is very slow. Yes. What you're saying, Seth?
Sir, can you say the difference between at least and at most?
Okay, good. So at least means minimum. Okay, at least two head. So that means there should be two head, and there is a possibility that we will get more than two head also. But the minimum should be two, not less than two. Okay, minimum should be two. So that means here we will take all the cases where we have two head as well as the case where we have a three head. So this is clear, Saf, at least. Okay. At most means maximum. Maximum there can be two head, but yes, you can select any event which have less than two head also, but the maximum should be two. So you will select two head, you will select one head, you will select zero. Clear, Saf?
Okay, sir.
Okay, great. Okay, Atif, what's the answer for the second one?
So it is a 3/7.
It is 3/7. Very good. Good. Now try the third one. Nabil, you have completed.
Doing that one, sir.
Okay, Nabil, please complete this and share your answer.
So is it one? Third one?
No, it is not one. What is E? E is at most two tail. So maximum there can be two tail. Okay, and but we can select less than that. So at most two tail. So we can select this. We can select this. We can select this. This one. At most this, and this. Okay. So 7. What we need to find? E by F. Okay. Now it is saying at least one tail. So minimum should be one, and there can be more than one. So at least one tail means this one, two, three, four, five, six, and 7. Okay. Now find the intersection, Nabil. What the intersection you will get? I have already marked here. Number of elements common in both E and F?
Sir, is the answer to the third one 1?
No, no. Why are all of you getting a 1 here? Please check here. At most 2 tails. Okay, so E I have marked here. This one. This is E with the red mark. F I have marked with the pink one. Okay, I will mark for you here. E I have marked with this, and F I have marked with this one. Okay, now find the intersection. Nabil, what is the number of elements in intersection you are getting? Count this. Any event which have 2 marks, so that
6,
is
sir.
6. 1, 2, 3, 4, 5, 6. So it is 6. And total in F, how many elements are there in F?
Sir, is it 7 by 8?
No. Adev, why you are getting here 7? Count this.
Sir,
Yeah.
there are 6 elements in F, right?
6 by? Yes, Nabil? 6 by?
Sir, F is having 6 elements, right?
F is having 7. 1, 2, 3, 4, 5, 6, 7. Okay, the pink mark is for F, at least 1 tail. So there should be 1 tail or more than 1. So 1, 2, 3, 4, 5, 6, 7. So this is 6 by 7. Is it clear, Nabil?
Yes, sir.
Okay. Atif, is it clear? Okay. Saf, is it clear? Saf, is it clear?
Yes, sir.
Okay. So shall we start next, Saf?
Yes.
Next one. Question number 3rd. Okay. Two coins. Two coins are tossed. Two coins are tossed. Okay. Find P E by F in each of the following. In each of the following. In each of the following. Okay. So first is E is tail appear. Tail appears on at least one coin. F is one coin shows head. One coin shows head. Okay. E no tail appear. No tail appear. F is no head appear. No head appear. Okay. Please try this question and share your answer.
So first one is 1/2 and second one is 0.
First one is Atif.
So first one is 1.
First one is 1. Yeah, that's correct. Check the second one.
Second one is 0.
Very good, Atif. Second is 0. Very good. Nabil and Saf, please confirm the answer.
So can you write the sample space of F in the first question?
So second one is 0. Right?
Yes, second is 0. Okay, I will write. First of all, we will write the sample space. So 2 coin are tossed. So we will get this HTTH TT. Okay. E is okay. You're saying about the first one, Atif?
Yes, so the first one, can you write events of F?
Yes. Okay, even of F. So here tail appears on at least one coin. Okay, tail appears on at least one coin. So that means HT, TH, and TT. F is one coin shows hit. One coin will show hit, so that means this one and this one. HT and TH. Okay, so what is intersection? E intersection F is HT, TH, so this is 2. Okay, and NF is 2. So 2 by 2. Is it clear, Atif?
Yes.
Okay, great. Saf, please share the second answer. Please confirm. Are you getting 0, Saf?
1 minute, sir.
Okay. Okay. So I'm going to start next. Fourth one. Nabil, you are getting 0 for the second one. Nabil,
Yes, sir.
Nabil, are you getting 0?
Yes, sir. I got 0.
Okay, okay, great. Okay. So line up at random for a family picture. Find P A by B. Okay. If if A is done on one end and B is father in the middle, father in the middle. Okay. I have written this is B. Okay. So what can be the possibility? Mother is here, father is here, son is here. Okay. Or then you can arrange these. Okay. Total. Next you can have MSF, FMS like this. Okay. So please arrange this and tell me the final answer.
So can you repeat what is MFS?
Yes. So here we have a mother, father, and son, and they are lined up for a family picture. So father will be represented by F, mother will be represented by M, son will be represented by S. Okay, so it is possible that father is here, mother is in the middle, son is here. Next, F is here, son is here, mother is here. Then mother is here, father here, son is here, mother here, son is here, and this next can be son here, father, mother, then son is here, mother and father. Okay, so total sample space is this one. Now please try to find the conditional probability.
So is it 1?
Very good, Atif. It is 1. Good. Let's complete this. After this, try question by fifth. Is it done? Saf and Nabil? Nabil, is it done?
Yes, sir.
Okay, great. Start fifth. Saf, fourth is done.
1 minute.
Saf, fourth is done.
1 minute, sir.
Okay.
The first one is 1, second one is 0. The fifth question.
The first one is 1 second is 0. Very, very good, Atif. Nabil, is it done? Fifth one.
Yes, sir.
Great. Saf?
Sir, can you say how the first one comes?
Yes, yes.
Second
I
one is
will.
getting clear, sir. First one,
Okay,
no.
okay. I will explain this. Saf, fourth is done.
Yes, sir.
What the answer you're getting in the fourth one?
1.
One. Very good. So please try fifth one, Saf. Okay. And let me know if anyone, if you have a doubt. Then I will explain the first part. Okay, Nabil? So just give me 2 minutes.
Yes, sir.
Sir, can you do the first one?
Okay, Saf, I will. Please check here. A is a subset of B. Okay. A is a subset of B. So that means, first of all, we will write the formula. PB by A is equal to N B intersection A by NA. Okay. Now, suppose B is having these element 1, 3, 5. Now they're saying A is a subset of B. So that means A is a subset of B. For example, A this. Now, okay. Now, what are the common elements, Saf, between A and B?
1 and 5.
1 and 5. And can we say that it is nothing, it is set A?
Yes, sir.
Okay. Read this. A is a subset of B. If A is a subset of B and you will try to find out the common elements, then always you will get the set A because it is a subset of B. So all those elements which are present in set A will always be present in B. So always you will get a set A. Is it clear?
Yes, sir.
So B intersection A will give you what? We can say N this. How many elements which are common in B and A? Same A. Is it clear? Sef?
Yes, sir.
Okay. And denominator we have Na. That's why we are getting one. Nabil, is it clear now?
Yes, sir.
Okay, great, great. So Sef, please complete the second part. Okay, confirm me, and I will. Is it done, Sef?
Yes, sir. Done.
Okay, great, great. Now next one, question number 6. A couple has two children. Couple has two children. Find the probability. Find the probability. Find the probability that both the children are boys. Both the children are boys. Okay, if it is known that the older child is a boy. Okay, second one, both the children are girls. If it is known that if it is known that the older child is a girl. Third one, both the children are boys. If it is known that at least one of the children at least one of the children is a boy. Okay, please try this one. Okay, I will write the sample space for you. So sample space can be what? B1 the first child, B2 the second one. Okay, B1 say it is a older one, B2 is a younger one. Next B1 G2, next G1 B2, next G1 G2. Okay, now please try this.
The first one is 1/2, second one is 1/2, and third one is 1/3.
The first one 1/2, good. Second is also correct. Third is also correct. Very good, Atif. Nabil and Saf, let me know once it is done. Okay. In the meantime, I will write another question. Saf and Nabil, is it done? Question number 6.
Yes, sir.
Okay, what the answer you're getting?
Sir, 1/2, 1/2, and 1/3.
Very, very good. Saf, 6 is done.
One mercy.
Yes, Saf, is it done?
Yes, sir.
Okay, great. 1/2, 1/2, and 1/3. You're getting this?
Yes, sir.
Great. Now please start question number 7 and share your answer.
Sir, is it 2/5?
Very good, Nabil. It is correct. It is 2/5. Very good.
Sir, how are we supposed to use that probability formula here?
Probability formula here. Okay. Let me solve this.
Sir,
A
I also got
dice
2/5.
2/5. Very good. Now a die is thrown twice, and the sum of the numbers appearing is observed to be 6. So this is given. Okay. So we can take this as a B. Numbers. Sum of the number is 6. Sum of the number is 6. Okay. Now dice thrown twice. Okay. Sum of the number appearing is observed to be 6. So what can be the possibility? 1 comma 5. Next is 2 comma 4, 3 comma 3, 4 comma 2, 5 comma 1. Only this one. Okay. What's the probability that the number 4 has appeared at least once? Okay. Now we will check this one. What is A? At least one. So what is the possibility that we will get at least one? So we can have 1 comma 4. We can have next one 2 comma 4. We can have next 3 comma 4. We can have next 4 comma 4. We can have next 5 comma 4. Next we can have 6 comma. Okay. Now what we need to find? PA by P. Okay. Now intersection. Find out the intersection between this. This is not matching. Okay, and this is what? NA intersection B by NB. So what is NB? NB is 5. NA intersection B. Now find out the common. Is it matching? No, we need 6.
How to find?
1.
How to know whether we should find P A by B or P B by A.
Okay, great. Understood your doubt. Nabil, whatever is given, we need to take here. Okay, because what is meaning by this? Probability of A when B has already occurred. Okay, so it's your wish what you represent which event with A or B. So that's your choice. But check here, B means this event. This event should always be occurred. So if you will read this question, then I will please tell me which event has already occurred.
The die is thrown.
A die is thrown twice and the sum of the number appearing is observed to be 6. So this is given. Okay, a
Yes, sir.
die is thrown twice and the sum of the number appearing is observed to be 6. This is given. Then we need to find out this one. Okay, so whatever is given, you need to use here, either A or B. So that's your choice with what symbol you will represent the event. Is it clear, Nabil?
Yes, sir.
Okay, so we will find this. Now you can solve this on your own. Okay, uh, Seth, is it done?
Yes, sir.
Okay, great. Uh, okay, I think there's will be more events with this one. Okay, 6,4. Then after this, we have 4,1. Then we have 4,2. Then we have 4,3. Okay, 4,4 we have already taken here. Then we have 4,5 and we have 4,6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be 10. Okay, now find out the intersection. Intersection is what? We need a sum appearing is observed to be 6. So first is this one. Okay, next is this one. So this is 2. So finally there will be one more. Just give me a minute.
It will be 4 by 10, sir.
Yes, that's good. So intersection is 2 and NB is 5. So final answer is 2 by 5. Next one. Question number 8. A die is thrown 3 times. Die is thrown 3 times. Events A and B are defined as below. Are defined as below. A is getting 4 on third die. 4 on third die. B is getting 6 on the first, 6 on the first, 6 on the first, and 5 on the second, 5 on the second throw. On the second throw. Find the probability. Find the probability of A given that B has already occurred. B has already occurred. Okay, please try this question and share your answer.
Sir, is it 1/6?
Very good, Atif. It is correct. Nabil and Saf, please let me know once it's done.
Sir, the eighth question, in the sample space, how many elements will come?
If we talk about the sample space, dice thrown 3 times. Okay, so 6 into 6 into 6. So that is 216. So there is no need to write the complete sample space. Okay, we don't need that. Just write event A and B. Okay. Let me
Yes,
know
sir.
is still anyone have a doubt.
So is it 1/36?
No, it is not 1 by 36. Okay, I will solve here. This is answer 8. Okay. Getting 4 dice thrown 3 times. Okay, so the total outcomes will be 216. How, like this: 111, 112, and so on. So it is not possible for us to write 216, and there's no need to write all these outcomes of a sample space. We don't need that. We need A and B. Now, what is A? Getting 4 on the third die. Okay, so that means on the first we have 1, 1, here we have a 4. 1, 2, here we have a 4. 1, 3, here we have a 4. 1, 4, here we have a 4. And so on. So, Saf, can you tell me how many elements will be here? How many total outcomes will be here?
30 elements.
30? 30 or 36? Check here.
Sir,
1,
36, sir,
1,
36.
30, 36. Saf, is it clear?
Yes, sir.
Okay, it is just like you are throwing a 2 die. Okay, 1, 1, 1 up to 6. So I will write here for your convenience. 1, 3. Then we will have 1, 4. Okay, and last we always have a 1, 4, 1, 5. And here 1, 6. Okay, then here we have, what's the next? We have taken 1, now take 2. 2, 1, 4, and so on up to 2, 6, and in last we have 4. So 6, 6, so on, we will get a 36. Okay, now what is B? Getting 6 on the first. B is much easier. Getting 6 on the first and 5 on the second. So 6, 5 is constant. Here you can have a 1. Here you can have a 2. Okay. Here you have a 3. Here you have a 4. Here you have a 5. Here you have a 6. Is it clear? Seth, is it clear?
Yes, sir.
6 on the first and 5 on the second. So here we'll get a 6. So 6 outcomes here. Now please try to solve this. And who has completed 8? Nabil, 8 is done now. Nabil, 8th one is done. You're on mute, Nabil.
1 minute, sir.
Oh, okay.
Sir, first one is 1/6.
Yes, it is 1 by 6. Good. Now please start 9 and Seth, share your answer for the 8th one.
Sir, 1/6.
Very, very good. This is the last one. Question number 9, this last one. Then your class will be over. This is for the ninth one. Okay, the first is 1 by 6. Great. Uh, Seth, sorry, I'm confused. This is the answer for the ninth one or for the eighth one?
9 to 1, sir.
Ninth one, no, the first is not correct, and second is also not correct. Sorry. So here a black and a red die are rolled in order. Okay. Find the conditional probability of obtaining a sum greater than 9 given that the black die resulted in a 5. No, that's not correct, Seth. Please again check this, or I will explain this to you here. Black
Sir, is question 9 question 1 by 3?
1 by 3, very good. The first is correct. Good. Sum greater than 9 given that B black die resulted in a 5. Okay, so what will be the sample space? You have two die, one is black, second is red. You are rolling that. The sample space will be again the same one as you normally get. On the first one, you get a 1, second one, next is 1, 2, and so on. So total will be 36. Okay, find the conditional probability of getting a sum greater than 9. So let A is sum greater than 9. Sum greater than 9. Okay, so A is what we if we have a 1, we can't take 1. Okay, we can't even take 2 because the maximum will be 2 comma 6, which will give us 8. We can't even take 3, so we will take 4. Okay, 4. Next you can take as 6. Take 5, 5, 5, 5, 6. Take 6, and with 6 you can take what 4, 4, 5, and 6. Okay, sum greater than 9. Okay, and after this, take B. B is what? B is a black die resulting in a 5. So first of all, we need to decide that the first, okay, first is black and second is red. Okay, first is black and second is red. So remember this one. So B is what? Black die resulted in a 5. So here we will put 5. Here you can have any number: 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 5. Here we have a 5, 5, and here we have a 5, 6. Okay, is it clear, Saf?
Yes, sir.
Okay, now please try to solve this.
Sir, the second one 2 by 15.
No, in numerator, no, it is not 2 by 15. Uh, in the denominator, how many outcomes are there?
I got 15, sir.
No, it should 18. It should be 18. Please again check this. Okay, given that red die resultant in a number less than 4. So less than 4 means you have 1, you have 2, you have a 3. So on the first one, you can have any number. So 666, you are getting 18. Again, check this one.
So is it 1 by 9 then?
Great. Nabil is correct. Very good. Atif, is it done? The ninth one? Atif, is it correct? Oh, sorry. Is it done?
Yes.
Same answer. For the first one, 1 by 3. Second is 1 by 9.
Yes.
Okay, great, great. Saf, is it done?
Yes, sir.
What the first answer is?
1 by 3.
So very good. Second?
I'm doing, sir.
Okay, okay. Please complete it.
Sir, I'm getting 1 by 6.
1 by 6. Which one? First or second?
Second one, yes.
No, it should be 1 by 9. How many elements are in the denominator?
18, sir.
18, very good. In the numerator?
3.
Why 3? It should be 2. Okay. A sum 8 giving that red die resulted in this. So sum is 8. Okay. So I will take A as 8. 8 means with 1 you don't have 2 comma 6, 3 comma 5, then 4 comma 4, then 5 comma 3, then 6 comma 2. Okay. A red die resulted in a number less than 4. So we have taken this one. So B will be what? A red die resulting in a number less than 4. So we will take here 1. We will take here 2 less than 4. So here we will take 3. So here you can have a 1. Here you can have a 1, 1. So 1, 1 up to 6, 1. 1, 2 up to 6, 2. 1, 3 up to 6, 3. Okay. Find out the common. So 2, 2 comma 6. So we will not have any number which have a more than 4 here. We will get only these two. Is it clear, Saf?
Yes, sir.
Okay, great. Okay, so your homework is assignment 1. We will share